In here, guys, we'll be talking about the second compartment of iron, and this compartment of iron is basically iron that is in the transport form, or iron that is in the plasma component of blood. Okay, so you could call it transport iron or plasma iron. Okay, and we are discussing the transport of plasma iron as a compartment of iron. Okay, we spoke about the compartments of iron where we said iron can be found in the hem, that's hemoglobin. Iron can be found in the transport form. Iron can be found in the storage form. Iron can be found in the tissue. Iron can be found in the bone marrow. Okay, so in this lecture, we'll be talking about this iron that is found in transport form, right? I'll be mentioning some important names, okay, which you guys need to pay attention. So this iron found in transport form is basically the smallest compartment of iron, but is the most active compartment of iron, okay? Ironically. And transport and storage of iron is largely mediated by three proteins. That's what? the transferrin receptor, and the ferritin, okay? So let me see if I could see these proteins here. I can see the transferrin, I can see the ferritin. All right, basically this transferrin has to bind to some receptors, okay? And these receptors are basically what we call the transferrin uh, receptor 1, okay? So iron in ferrous form is oxidized by what? Ferrioxidase. That's a hephaestin back to what? Iron in ferric form. Okay, and iron in ferric form is the only form of iron that can bind to transferrin. Okay, so if iron is already in the ferrous form, it has to be converted back to the ferric form so that it can bind. Okay, so it can bind to this thing, um iron in plasma. It can bind to transferrin in plasma. Okay, so now when iron binds to the transferrin in plasma, the transferrin can take up to 2 atoms of iron and deliver to tissues that have what? Transferrin receptor 1. Okay, so for examples, the erythroblast in the bone marrows have these receptors for transferrin receptor. Okay, they have these transferrin receptors, right? So this transferrin will now take iron and give it to these tissues that have receptors for the transferrin receptor, for the transferrin. Okay, so now for example, erythroblast in the bone marrow, this incorporates iron into hemoglobin. Okay, so transferrin in beta globulin glycoprotein synthesized. Okay, sorry. Transferrin is a beta globulin glycoprotein that is synthesized predominantly or mainly by the liver. All right. When transferrin binds to the receptor, it forms a transferrin receptor complex. Okay, and this transferrin receptor complex is taken up by a process of what? Receptor mediated endocytosis. Okay, so we've spoken so much. I don't know if I can be able to illustrate this. Basically, you guys will see this transferrin receptor. When the transferrin here binds to the receptor, it forms a transferrin receptor complex, and this complex is taken up by the what? Receptor mediated endocytosis. Okay, to be taken into the cell by receptor mediated endocytosis, right? And this is how iron exists in the transport form. Okay, the various mechanisms converting iron to this, the proteins that it binds to, the types of proteins that actually ensure that iron remains in the transport form. That's the what? The transferrin receptors, and the ferritin. Okay, so that's it, guys, and see you guys in next. All right, I'll be discussing the next compartment of iron, and that's iron in storage form. Okay, bye for now.